Lesson 2-2, Solving One-Step Equations. Essential question. How do you solve a one-step addition or subtraction equation? So in this lesson, rather than having a vocab word, we have a question we're going to answer to start off. What are inverse operations? Well, inverse operations are just opposite operations. So adding and subtracting are inverse operations. So the opposite of adding would be subtracting. The opposite of subtracting would be adding. And then multiplying and dividing are opposite operations or inverse operations. The opposite of multiplying is dividing. The opposite of dividing is multiplying. So in order to be able to solve all of these equations today in this lesson, we're going to have to do the opposite operation or the inverse operation in order to isolate the variable. So our first equation that we have to solve is x plus 7 equals 10. So the first thing I'm going to do on every single equation is draw a line or train tracks through my equal sign in order to help keep my problem organized. This will remind me that whatever I have to do on the left side of that line, I also have to do on the right side and vice versa. So again, my goal is to isolate the variable or get it by itself. So the way to get this x all by itself and get rid of the plus 7 is going to be to do the opposite. So instead of adding 7, I'm going to subtract 7 on both sides. So if I take 7 minus 7, that gives me 0. So I'm just going to put a big X over that, meaning it's 0, it's gone, I don't need it anymore. Then I'm going to bring my X down, because that's all I have left on my left-hand side. Now whatever I did on the left, so since I minus 7 on the left, I have to do that on the right-hand side as well. So I'm going to take 10 minus 7, and I'll end up with 3. Now, if you wanted to, you could go back and check your answer. So I could take that x equals 3 and put it right here and check, does 3 plus 7 equal 10? Yes, it does. So that's how I know it's correct. All right, then I've got 20 equals x plus 8. So I'll start by drawing my train tracks. Now you'll notice this time the variable's on the right-hand side of the equation. That doesn't matter, I'm still going to take the same steps to solve it. So I want to get x alone, or figure out what x is. So the way that I'm going to do that is instead of adding 8, I'm going to subtract 8 from both sides. So then that gets rid of these two 8's. And gets x all by itself. 20 minus 8 is 12. I am done. And again, I can check my answer. 20 equals, instead of x, I'm going to put that 12. 12 plus 8, yep, 20 equals 20. This time I've got negative 11 plus x equals negative 5. So this one looks a little bit different than the last two. I'm still getting x alone, but I'm trying to get rid of a negative 11. You have to look at that negative sign in front of the 11. Yes, I have a plus in the middle, but I don't want to add, or I don't want to subtract 11, because negative 11 and negative 11 would give me negative 22. I need to make 0. So I have to think about what will make 0 with negative 11, well, positive 11. So I have to add 11 to both sides. Negative 11 and 11 make 0. So I'm left with x on the left-hand side, negative 5 and 11 make 6. If I go back and check, negative 11 plus 6, negative 11 plus 6 is negative 5. So that is correct. So that last one was a little trickier. You just have to think about what can I add to this number to make 0. What's the opposite of negative 11? Positive 11. All right, now on this next slide, we're going to get to subtraction problems. So those last ones were all, you saw an addition problem in each example. These are all subtraction. So we'll start with x minus 9 equals 4. I'm trying to get x alone, the opposite of minus 9. Inverse would be adding 9. Negative 9 and positive 9 make 0, so I'll x those out. X equals 4 plus 9 is 13. If I wanted to go back and check, 13 minus 9 equals 4. 4 does equal 4, so that is correct. 7 equals x minus 10. By itself, the opposite or inverse of minus 10 would be adding 10 to both sides. Negative 10 and 10 make 0. 7 plus 10 is 17. If I plug this in over here, 7 equals 17 minus 10, and 7 equals 7. All right, this one looks a little bit different than what we've done so far. So x minus a negative 3 equals negative 8. Now before I do anything to both sides on this one, I want to do something else first. Whenever you see minus a negative, you want to change that into a plus or a super plus if you want to connect them. But this has now gone from a subtracting problem, subtracting a negative 3, to an addition problem. So now, if I wanted to, I could rewrite this as x plus 3 equals negative 8. And now I have to subtract 3 on both sides. Negative 8 and a negative 3, if you add two negatives together, it makes a bigger negative. So I have negative 11. If I go back and check this one, negative 11 minus a negative 3 equals negative 8. Even over here, I have to change this into a plus. So negative 11 plus 3 equals negative 8. Negative 11 plus 3 is negative 8. Negative 8 equals negative 8. So my answer is correct. Summary. To solve a one-step addition or subtraction equation,